I'm Roddy McLean. I'm Director of Agriculture for NatWest Bank, and we're very pleased to be supporting today's conference. The wider agricultural sector is an important sector to the bank, with 150 dedicated agricultural managers around the country, and we lend almost $5 billion to the sector, giving us a market share somewhere over 25%. With 4 speakers in this session, and I look forward to hearing from them over the next hour and 20 minutes or so. Professor Simon Pearson, Martin Collison, David Ball from Neamley has taken off to Canada, I think to catch the early season snow that's out there, but he's ably replaced by Andrew Fuller, their technical director, and Ali Capper will come in at the end of the session. Speakers, you've got 15 minutes. If you go over, you won't get questions, so the choice is yours. Our first speaker is Simon Pearson. He's the founding director of the Institute of Agri-Food Technology. Previous life, he was a technologist with M&S, and he's been a commercial and managing director of Winchester Growers, who I understand major in daffodils and packing of other flowers. Currently, his research interests are quite varied, but he's got a focus on technology, applications, and including robotic systems. Simon, the floor is yours.
Right, well, thank you for the opportunity to come and talk to you today. I think a lot of you I know, so I hope I paid all my bills in the past. So I'm going to talk about agri-robotics and the digital transformation of agriculture, or can be horticulture. So I'm a professor at the University of Lincoln, and I'm also the PI of this network, which is the Internet of Food Things Network, which is an EPSRC network, which is to try and pull together the academic community in the UK to work on agri-food and horticultural challenges, and then connect that to industry. So that's a big part of my job. It's networking and pulling people together. So what I wanted to do was really start with a bit of a reality check, just to warm up the room. So why are we so worried about robotics and automation? Well, why is the government worried about it? It's about productivity, and I just want to show you why the government's worried about it. This just shows productivity from different sectors. At the back of the room, you probably won't be able to see it, but I'll just walk up to it. So these lines show different sectors of the economy. When the government talks to agriculture, often it comes out with a stick and says automotive. And you can see the productivity curve from 1997 from automotive, which is increasing quite nicely. After 2008, actually, it stepped up very, very rapidly with lots of investment. It's doing very well. This is food manufacturing, which is our biggest manufacturing sector in the UK. It's doing okay, but not at the same rate as automotive. Other areas which are driving the economy, things like food service and couriers are driving productivity. But agriculture, it's absolutely flatlined since 2007. So that means the efficiency gains from automation in agriculture have barely offset any inflationary pressures. That's not the case for horticulture. And I think one of the big things that I've really noticed over the last few years is there aren't very good stats for horticulture. I think we're in a lot better position than the stats say. But in agriculture, it's a fairly disappointing performance. Lots of sector issues, so difficult sectors to drive productivity in upland farms, etc. But it's not a great success story. Horticulture is, I think, a success story, and I think we need to know what those numbers look like, and we don't. So why are we all worried about all these issues? So it's demographics and politics. We know about Brexit. I won't go on about that. But access to labour is absolutely critical to this industry. But it's actually critical to global industries. And I think this is the important thing that's often missed in the debate. So in the far corner, just one example, you've got America, got the same migrant access issues as the UK, Donald Trump and his wall. In the top line, that's the demographics of the Chinese population between 2010 and 2050. You'll see on this side, majority of the population in China is now 40 to 44, but we know what's going to happen in 2050. These populations are going to age, and there'll be more people over 65 in China than the entire population of Europe. China knows they've got huge demographic problems, and they are automating at an enormous rate. If you go to Japan, I was in Japan last week, they are automating at an enormous rate. If you go to developing countries, they are automating at an enormous rate. So this is not just about UK PLC, this is how UK PLC is competitive against that international set. And believe me, they know they've got a problem as well. Brexit actually accelerates the need for us to automate. So I think that will be a driver of change. What is the benefit of automation? We don't know. We do know a little bit about food manufacturing. So Martin Collison and I last year worked with Jürgen Meyer on the government's industrial digitisation review, which quantified the impact of automation and robotics and Industry 4.0 on the food industry. So food industry is our biggest manufacturing industry, and we worked out with Accenture, HVM Catapult and Siemens that actually if you apply Industry 4.0 in food manufacturing, the net benefit to the UK economy by 2027 is £55 billion. So when those numbers came back, I nearly fell off my chair. I rang up Martin. I said, these cannot be true. He said, stick with it. It's a good number. So Industry 4.0 in food manufacturing is massive. We've got no idea what that impact is in horticulture, but it's going to be a big number, and we need to get those numbers quickly. When you're talking to government, these are the sort of numbers that make people, that really, really do fix people's thought processes. So just to give you an idea of the pace of change, we're in a world of exceptionally fast change. And Martin and I were at a conference quite recently, and I thought these were great pictures. And this just shows the rate of change of technology. And this is when the car was introduced in America. And I just want to show you these two pictures. And this is a picture of New York City on Easter morning 1900. And there's one car. There it is. That's that one car. This is 13 years later, same street, same day, and there's one horse and cart. Can anyone see it? This is a test. It's there. So that was the impact of the car in 13 years. But digital technology, it's accelerating at an even far greater rate, and it's not just about robotics. It's about blockchain, it's about IoT, artificial intelligence. These are transformational technologies which are changing lives. And it's quite clear now for young people, and I think there's a study done quite recently, for young people who are at university now, probably half of them are going to do careers that haven't even been invented yet. It's just striking. So what are the digital technologies which are going to transform from the world? So there's a number of things. I'm going to talk about the Internet of Things to start with. So the Internet of Things you hear about, not many people know what it really is, but it's really a way of digitally connecting thousands of machines so that you can control them in two directions. You can take information in and push out with control. So that is transforming industry. And here's a nice example. We work with a company called IMS. And what we've done at Lincoln is work with this IoT company to connect all of the refrigeration systems of Tesco, of which there's 112,000 refrigerators across the UK, into the national grid demand-side response tariff. So you imagine now we're at a point where we can centrally control from one server in Milton Keynes the action of every single refrigerator in Tesco, in Sainsbury, in Morrison's, around the world, and you can do it in a coordinated way. Why do you want to do that? Well, if you go back to Tim's point, the biggest battery in the United Kingdom, it's not a battery in a 40-foot container. It's all of the food in food refrigeration systems over the United Kingdom. It's a battery of far greater scale than anyone's ever thought of, because it's the thermal inertia in the food. And what we can now do is, with the Internet of Things, you can connect that battery into the national grid. So we're seeing a massive acceleration of technology. And on the side there, that's one Tesco store where we shut down a store, and you can shut it down for a very short period and do it in a very safe manner. The next thing is robotics, and we heard a wonderful talk from Martin. We're going to hear from Matt and Kit a bit later today. But I just want to show the rate that robotics accelerating. Now I went to Japan 2 years ago to look at the state-of-the-art, world's best strawberry picking robot. Here it is. And this is next to Fukushima reactors, so I am glowing. And I've got this, it's 40 minutes long, this video, and it's painful. You'll chuck yourself out the window. Here we go. And when you go on and see these robotic things and see them on YouTube, just take it with a pinch of salt. The editing's quite... Here you go. It's pathetic. Let's spat that one out. I love that bit. Hey, go on. Yeah, all right. Yeah. So I don't think Hall Hunter's going to be buying many of those very quickly. But that was 2 years ago. The point here is the acceleration of the rate of technology, and this is the robot we're developing at Lincoln with Norwegian University of Life Sciences. And this is a strawberry picking robot, and it takes basically a cup and it's swallowing up the strawberry. There's 3 robots on here. That's the robot platform and 2 parallel Cartesian robots. And we've now got this picking at the same rate as a human picker. In fact, we're pretty sure we can go faster than the picker, but there's some phenomenal challenges in robotics that need to be solved. The most difficult problem is control in a very unstructured, cluttered environment, which is a horticultural environment. So where you've got dense clusters, lots of occlusions, the vision systems can't see the fruit. You've got to get into those structures without damage, and that's the stop point at the moment for robotics. Lots of excitement around robotics, and I think robotics are definitely here, absolutely here. But my message is that, my view, we're going to be about 5 years from real serious deployment of these robots. Now, we're very concerned that when we see lots of articles in the Times, politicians start to think that they can get robots to solve all these problems. Well, you can't actually go out and buy a single robot yet. It's going to be about 5 years. Then they'll be transformational. What we can't have is a situation where the industry doesn't have workers in that interim time while robots are coming. It's critical. If anybody talks to policy, if they say robots are going to solve it, believe me, they probably can, but not for another 5 years. So we just need to make sure that messaging is consistent. And this is the robot going, and you see some active vision control here where the robot's actually manipulating around some strawberries. So we're getting there. We are getting there. Martin's group's doing some amazing things. Harper's doing some amazing things. Matt's group's doing some amazing things. This is our what we work on at Lincoln. So this is actually the hardware's built in Norway by NMBU, Norwegian University of Life Sciences. We developed the software for the robot, and this is a field robot, and this is tested in Lincolnshire. Look at that mud. Absolutely marvellous. These things are really amazingly robust. That thing can carry about 300 kilos. We've now got it operating in a fleet, and it's just having fun. This is for fruit picking. It's a happy little robot. That just shows the power. There's 4 500-watt motors in each of those wheels. So it's got real torque. The battery won't last that long with that, but a normal operation, the battery lasts about 8 hours. This is easy to carry around. And this just shows a very high payload. This is a 300 kilo payload. This is for different tools. This is for phenotyping, same robot but different frame. This is with a robot on a robot. This is a compaction sensor. So it's measuring compaction through soil. Here we go, it's a probe. And then the robot can now just wander around the field and map it independently. It's quite amazing. And I'll just 5 minutes. God, blimey. This is for UV treatment of strawberries. So that cures powdery mildew. I don't know how it works, but it does work. We're testing it at Lincoln at the moment. It is incredible. UVC you can't apply because of human safety issues, but you can with a robot. This is a rail robot for greenhouses, and this just shows the robot applying UVC in cucumbers to stop powdery mildew. The robot is doing this itself. So it's trying to work out how to get on the rails. Greenhouses are nice for robots because they've got rails, and it's going onto the rails. Here we go. Done it, and bing, UVC. That is the most amazing technology. I can tell you that works. Particularly the UVC. So that's robotics. The other thing I want to just quickly move on to is artificial intelligence. So that's deep learning. And just to show you the power of this and how quickly we're moving on, this is a deep learning project we've done on locust detection. Here's my little friendly locust. Can anybody see can anyone see a locust in that image on the other side? Yeah, well done. Yeah. So that, yeah, you can just see it. That we used artificial intelligence and we identified a locust in 0.1 second, 0.1 of a second. And so we're getting situations now where AI is better than a human operator at spotting these things. Put that in horticulture. You imagine in detection of diseases, pests, you name it, that it's transformational. 0.1 of a second. The second thing here we've done is use artificial intelligence to recreate the performance of a machine. So we've taken data from 9,000 refrigerators, and the model has modelled how a defrost cycle would work in a refrigerator. So it's taken this huge amount of data and turned it into an intelligent output, which is of use for us in terms of our Tesco project. So 9,000 machines all collaborated. So we're now getting to the point where big data is useful because we can get intelligence out of it. That's the breakthrough point that's coming. My last slide, second to last slide, because I know I'm getting the evil eye from Ian, is there other technology coming forward? Blockchain, it's much discussed. So that's a new way to develop food traceability. So you can immutably link different parts of the food chain up. So all the way from grower, all the way up to consumer. So in theory, a consumer could look back from a label down to the whole way that a produce has been produced. And in the Walmart, for produce producers, for lettuce producers, Walmart in the United States have made blockchain applications mandatory for their suppliers because of the E. coli issue in Yuma last year. So blockchain's coming at us. It's not a ready solution at the moment because the data required for the food chain is vast, but that's going to come at you. Immutable traceability, which connects everything so you can analyse your whole supply chain in an instant. So that's it. So that's my message. Food's digitising. It's not just about robotics. Robotics are transformational. We need 5 years, though, to get that into industry. 5 years, please, government, where we have lots of people, please. And if you want to keep in touch, just keep in touch through our network, which is foodchain.ac.uk, and we're reporting on and talking about lots and lots of things around digitisation.